Now, let me introduce our first speaker from Intel, Andy Fingerhut. Andy Fingerhut has decades of experience on hardware and low-level control software for large-scale switching fabrics and network processors. He's been serving as the co-chair of the P4 Architecture Working Group since 2018, and he's a principal engineer at Intel working on programmable switches and NICs, enabling new data plane features and exposing them in the language. Andy, take it away.
Great, thank you, JK. Good day, everyone. P4 on the move. I want to start off and just say my goal here is to give just a few highlights of news items I'm aware of in the P4 world from the past year, since the past May P4 workshop, spanning over the p4.org working groups, over open source projects, over a little bit of research that's been done in academia, and of news items in industry. The bad news is I know only a small fraction of what's been going on in the P4 related world in the last year. I've gotten some help from colleagues to think of news items to include here. But the good news is, the reason why I don't know it all is because so much is going on by so many of you and others throughout the world that I don't think one person can any longer keep track of everything that's going on in the P4 related world anymore. So this is my disclaimer. This is by necessity, a smattering of news items that I'm aware of and hopefully will be of interest to you. And if I don't mention something that is of interest to you, I apologize that I didn't get to it. It wouldn't all fit in the talk anyway, I don't think. So I'm being very selective, and I welcome your questions and comments afterwards if there's anything that you'd like to call out that I've missed. So I'll start with the p4.org working groups. I'll start with the applications working group has been led by J.K. Lee and Mukesh Hira for several years now, and their focus has been on defining in-band network telemetry in a couple of specifications. So this year we are welcoming very gladly 2 new co-chairs, Nandita Dukapati at Google, Rongpan at Intel, who are very deep subject matter experts in the area of congestion control. And there have been no meetings announced with the new rebooted working group yet. But if you're interested in when those meetings start and joining in, there's a link there at the bottom where you can join any of the p4.org email lists, including the P4 apps email list, where such announcements of meetings and I hope meeting notes will be put and will be sent to. So definitely looking forward to what these 2 come up with, as well as those that participate with them. That'll be covering congestion control, end-to-end from hosts, NICs, switches in the network, and interaction between those. So there's been a lot of exciting work done earlier, and I hope to see how they put it all together. In the API working group, there's a new release, version 1.4 of the P4 runtime API specification imminent, if not already published. I haven't checked this morning. There's just a bullet list of a couple of items. I asked Stefan Smolka, and he asked me to call out the adding of per color counters for meter entries in the runtime API specification, but there's other work that's been going on there. I don't attend all of the API working group meetings, but I do attend some, and I wanted to call out a few things that I've found of interest in the past few months. One is there was a presentation of TDI, the table-driven interface, in one of the meetings, which got a lot of questions and significant follow-up interest in questions in later meetings. And so at least there's some possibility for that to become perhaps have a specification through that API working group. That remains to be seen. There has been some open source work in various P4lang GitHub repositories with at least an initial implementation of TDI that you can find in those repositories. And another proposal of interest that I saw related to the portable NIC architecture working group, several engineers from NVIDIA have been doing performance analysis in a lot of NICs. There certainly are switches with DRAM-based tables and multi-million table entries, but it's much more common in NICs to have DRAM-based tables with 10+ million entries in the tables. And so if you actually want to use P4 runtime API to add 10 million entries to a table, performance of how fast you can do that is critical. And so several engineers have worked out, done a lot of detailed performance analysis of the CPU performance in the control plane for adding table entries at high rates and coming up with proposals for how to improve that. So I believe that's still work to come as far as the P4 runtime API official specification, but that looks promising and a very useful contribution from the community there. And the architecture working group, the focus for the last year has been on defining the portable NIC architecture. One of the really cool things about this, I worked also in the architecture working group when we were defining the portable switch architecture, and we did have multiple industry and research participants in that, but not as many as we have for the portable NIC architecture. So this is really heating up. You can see a list of device vendors and NIC users and purchasers down there at the bottom. That's not a complete list. There are other people involved as well. I just wanted to give a sample, but you can see at least that there's a pretty broad representation of people, vendor and user side. We plan to release an updated specification soon. And just as an example, a hot topic or what's been taking up most of our time in the recent meetings has been just hammering out details on data plane add-on MIST tables and uses of those in features like connection tracking and making sure that we're adding enough functionality to make them useful for developers and yet implementable by developers, by vendors, sorry. In the language design work group, there's a new release of the language specification coming out, including improvements and fixes of the type system and many other clarifications and improvements there. One thing I wanted to call out in the language design work group, so in the P4Lang GitHub organization, the P4C open source compiler front end, it's quite common for many people that want to develop a P4 compiler to start with that open source P4C front end and then write their own backend for their particular target. This is done quite frequently. There's a lot of work done on that front end that's great to reuse. Andrew Pinsky at Marvell Semiconductor has been attending the language design work group meetings in the last few months. And it turns out that his interest is he's writing his own front end P4 compiler, front end and back end, I believe. And he is implementing the front end independently of the P4C. Now, I guess I should say, when I say independently, he's definitely looking very carefully at the behavior of the P4C front end when writing his, so that he gets, looking for compatibility of his implementation of between P4C open source front end and the language spec, but also looking for differences between those. And he has a fine eye for detail and has filed many issues on both the specification and the P4C compiler while doing this development. So thank you, Andrew, for that. That's been wonderful to see. Looking forward to what you come up with. In the open source world, I just want to mention as background, so I don't know, some of you may know that there's several open source, there's a forum.p4.org website, and there's a P4 Slack community that I often answer questions from, I suspect often beginners in the open source P4 development tools. And a common question that has come up multiple times over the years is, how do I take the BMV2 software switch and optimize it for packet processing performance? What compile time options do I need? What do I need to do to make it go faster? And this question came up often enough that Antonin Boss and I wrote an article that's part of that repository now that says BMV2 wasn't originally designed for packet processing, optimizing packet processing performance. It's a development, P4 development and debug tool. So interesting in open source now is a couple of software switches where one of their design goals is optimizing software packet processing speeds on general purpose CPUs like x86 and ARM. And one of those, if you want to run your software switch in a user space process with some kind of options for kernel bypass, is a P4 compiler to the DPTK backend. This project was started before more than a year ago, but significant in the last year has been very steady progress of completing the implementation of all the portable switch architecture features. And they are also tracking changes and updates from the portable NIC architecture specification as those are made. and they've been asking, several of the team members have been asking me questions about details there. So that's very exciting to see. And I know when I say that they're targeting, optimizing for packet processing performance, some of the optimizations I believe might still be work in progress, but that is certainly the design from day one has been targeting that. So that's been an explicit goal as opposed to a non-goal. Another, if you want to process your packets inside the Linux kernel, there's the eBPF backend. So there was an eBPF backend for several years for P4C, but which developed by Mihai Budiu several years ago, and others. I'm sorry, I've forgotten the other name. The other names involved, but it was always Mihai was actually a little bit disappointed that it didn't seem to be widely used, and he knew it was a partial implementation of a small P4 architecture. So Tomasz Osinski, I believe, has led the effort to open sourcing this. I believe this eBPF backend was developed several years ago as proprietary code originally, and now it's being open sourced. And it is a much more complete implementation of more P4 language features targeting the eBPF backend. So thank you, Tomasz, and others who worked on that project. That's very cool to see. It's been coming out quite rapidly this last few months in open source. In other news, the Open Networking Foundation has open sourced the entirety of its portfolio of production-ready platforms. There's a news announcement there at the bottom if you want more details, but for example, including Pins, Onos, and Stratum as projects that folks in the P4 world have most likely heard about, but there are all these others that they're open sourcing as well. So that's a big, significant set of projects there that are now will be available in open source. Great to see. For P4 in academia, I have I've done just kind of a brief summary. I don't have paper titles here, sorry, but I did go through SIGCOMM 2021 papers and hackathons, NSDI 2021. My apologies, JK pointed out to me my mistake of, I went through NSDI 2021 very carefully, and then he pointed out to me that was April 2021, Andy. And so NSDI 2022, I unfortunately didn't summarize. That was in last month. And so I missed my 1 year window there, but I can create an updated list here, and I wouldn't be surprised if it looks similarly for NSDI 2022. For SIGCOMM 2021, there was a hackathon featuring P4 on Raspberry Pi, very inexpensive hardware there. Great for students doing projects or any hobbyists. Both these conferences had 5 or 7 papers where their P4 wasn't, I wouldn't say the primary subject of the paper, but they took their main data plane algorithm and they implemented it in P4 and evaluated it in their research paper. And there were 3 more papers across the 2 conferences where P4, I would say, is a major part of the work. It was integral to their research. P4.org, the website, has a publications page, and I went through the list of those that were published in the last year, and I removed all the duplicates from the NSDI and SIGCOMM, and there were 20 additional papers published across journals, conferences, and workshop listed there. And I also wanted to mention the Internet Connectivity Research Program. A colleague of mine at Intel spends a lot of time reviewing research papers that use Tofino for accuracy and completeness, and then we publish many of the papers that they do there. Sorry, I haven't counted those for duplicates with the above. So lots of work going on in research and academia here, and I'll mention a few more later. I want to switch over and mention a few news highlights for P4 in industry next. Again, so this is even, if anything, more partial and more a few highlights I'm aware of, because so much that goes on in industry is not even, I can't say it's under non-disclosure agreement, but these are a few public announcements that I could find. One big news: AMD completing acquisition of Xilinx. The acquisition was announced before this past year, but the news this year is that they have finished all the legal documents and work and financial work to actually complete this. Another newsworthy part of this, Gordon Brebner, who some of you may be aware, at Xilinx before P4.org existed, he was working on a programmable data plane language for their Xilinx FPGAs. And then when he realized P4.org when he saw P4.org was being formed, became a co-chair of the language design work group and has been an advocate in using P4 the language in Xilinx products extensively since then. He's also the current chair of the P4 architecture working group, and as I believe part of this acquisition, he's been named a senior fellow at AMD. So congratulations, Gordon. Way to go. Onwards and upwards. I don't have a good quote from this one, I'm sorry, but this is certainly big news. There's a mention of this later that someone else mentioned this, I'll show you. So AMD completed acquisition of Pensando, and with their distributed service card, and they definitely have a P4 programmable, sorry, whether you call it SmartNIC, IPU, or DPU. I've forgotten the party line here for a second, sorry, my Intel colleagues. But that category of programmable NICs, Pensando is definitely a very interesting products in that space. Another project I wanted to mention I'm aware of and been involved with a little bit is DASH, which stands for Disaggregated API for Sonic Hosts. So Sonic has been used by many for defining a fairly high-level control plane API for layer 3 and layer 2 switches in the network, and routers/switches, and their common layer 3 and layer 2 features, having a control plane API for that. So that's been around, very useful for years, and this project is intentionally expanding and adding new Sonic APIs, SI APIs, for new data plane features that programmable NICs are a good target for, at least some of them. So for example, TCP connection tracking, a general theme in all of this is taking advantage of the price, power, performance improvements you can get in specialized devices, like programmable switches NICs versus general purpose CPUs. And so for example, instead of taking the first packet of a flow and doing a fancy packet classification in software and then putting a cache entry into the hardware for future packet forwarding, handling even that first packet, perhaps more slowly, but in the data plane, is one of the goals of Dash here. I wanted to mention, just to be very clear here, P4, it's not a necessary or integral part of Dash. You can make a Dash compatible product. The plan is you can make a Dash compatible product using SI APIs only at the top, and the data plane can be implemented however you want. It doesn't have to have P4 involved. The reason I mention it is there are multiple vendors attending meetings involving Dash behavior and implementation. And one of the goals is to create an open source reference model for the Dash data plane. And P4 is a choice of multiple vendors. They would prefer to implement that reference model partially in P4 and control plane software. And it seems to me extremely likely that some of those vendors may also use P4 under the hood to implement compatible devices for this that meet these feature sets. So that's an interesting, and another reason I mention it is there have been several people involved in the working group for creating this reference model that have been going to the portable NIC architecture meetings and asking for features there that could help them in this reference model implementation. So there's some interaction there. If we look outside of Silicon Valley, I looked for a few examples in around the world, especially in Asia. Alibaba, this is also an example of industry and academia collaboration. There's a couple of research papers published by engineers at Alibaba in several universities. Sailfish is cloud scale gateway acceleration and programmable switches. Aquila is a verification system where they tried several other verification tools for testing their deployed P4 programs in network switches and found some things lacking and fixed it. Created a new system that they felt met their needs better for verifying these systems. And I put a quote in there from that just for the industry aspect of this, focusing on the scale at which they're deploying systems. They have billions of users for their network, and they are deploying many programmable switches in their edge network for features like load balancing, firewall, and DDoS defense, and using their Aquila system to help them verify it. Some other news in Asia, ByteDance has published a paper here on Tiara, a stateful L4 load balancer. And later, I believe in this P4 workshop, China Mobile and others will be presenting some progress on an SRv6 open source implementation. So P4 on YouTube. Many of you may be aware there is a p4.org channel on YouTube, and it does have some interesting technical talks, and I recommend you go look for introductions and tutorials on P4 from earlier and more recent talks there. And hopefully we'll be publishing more. P4.org will be publishing more there in the future. However, that's not what I came to talk about today. This is a channel on YouTube pointed out to me by a colleague at Intel that he was just he was watching it for other reasons, and he was surprised to hear it mentioning P4. So I just thought this seemed like a fun example to mention, a little bit off the beaten path. There's a Serve the Home channel on YouTube. I don't know his full name. There's a gentleman named Patrick who, oh my gosh, even after I've had my morning coffee, I cannot be as energetic and excited and dynamic as he is on the screen. He's a really exciting speaker to watch. And he's had several recent videos where he mentions P4. Now I should say, these are not tutorials on P4. You're not gonna, I don't think these are things you're gonna go learn P4 from. He's really giving, taking these features like Pensando's distributed service cards or Bluefield 2 and Intel products, and just looking at all the kinds of features they can implement. So here's a mention here. He has one where he's also looking at this, noticing the AMD acquisition of Pensando. Another talk that another one of his videos, he actually implements. He's got right on his home server system a ZFS file server that has one of these products, these DPU products in it, and 3 SSD drives, and no general purpose x86 CPU anywhere in the system. The DPU device is interacting with the SSD drives, and so he's building that in his home and showing how to do it. So that's an interesting thing you might want to check out. So in summary, lots of things going on. Jump on in. In particular, for the P4.org working groups, there's a calendar at the link here. You can see all events planned and coming up. Usually they should all have links to Zoom or other online ways to join them. You can join the mailing list of that link. I wanted to call out a highlight of a few technical things in the P4.org working groups that I'm aware of coming up that are not done, but in the works. There's a P4 namespace or module system that's being discussed that would, when that work group believes they have something useful, they're going to go back to the language design work group and propose adding it there. There's some work involved in most P4 architectures like PSA and PNA today are defined usually with 70, 80 page spec with lots of English, some pseudocode. But there's some work involved defining P4 architectures precisely in code versus natural language, which would make them perhaps easier to turn into executable and or verification tool artifacts straight from that specification. Alan Lowe at NVIDIA, involved in the portable NIC architecture work, has proposed some new syntax for defining state machines in the data plane that looks interesting, and we hope to hear more from Alan on that proposal and see whether that's appropriate for adding to the language or other architectures. Here are my Intel notices and disclaimers, and I will just say thank you and glad to be here.
Thank you very much, Andy, for giving us a nice summary and recap of the p4.org and also community news of the year. So you are here actually as the chair of the P4 technical steering team, on top of many other contributions you've been making so far for p4.org. So looking back the last, I don't know, maybe 7-8 years, since 2015, and we see, I think, the pretty rapid growth in terms of P4 ecosystem. And what do you really kind of expect or want to see in the last year as another maybe big movement happening in the P4 community? Or more specifically, what kind of maybe small but very impactful activities you want to see more in the open source community under our leadership, working group chairs, etc.
Sure. So let me start with the last question, then I may ask you to remind me of the first one. But on the last part, I one of the people I talked with, getting ideas for this talk is Nate Foster, who's co-chair of the language design work group, and we've collaborated for years on various things. And one of the last things I mentioned was this idea of precisely specifying P4 architectures in code-like format. And I mentioned, so one of the things that maybe has been a little frustrating in the open source world is when people have ideas for either creating their own P4 architecture or extending one of the existing ones. It's not a beginner level task to jump into the open source development and kind of quickly get your bearings and add that. And so at least that project and some others, it would be nice to see if there could be more documentation and or examples of how do you extend those things. So there's been work on this done in the past, and I think just sort of collecting them together and giving kind of a guide would be a nice thing for that. I mean, it's a little self-promoting maybe, but as far as like, to me, the portable NIC architecture group, I think this idea of, for example, the add-on MIST tables and defining new capabilities there, it's not that they're new hardware capabilities that nobody's ever thought of before. People have done add-on MIST tables for decades in switches. This is just sort of bringing it to P4 in hopefully a way that's standard enough that multiple vendors can agree, yeah, that's the way I'd like to see the source code, and that's the way my compiler will accept it. And so I think just it's maybe more of a, bringing these features that have been around for a while and giving them a standard way of writing them in P4 would help them be more widely understood and used, I think.
That's an interesting answer. Thanks. Thanks for re-emphasizing those interesting new features coming up. There is actually two questions in the live Q&A from Victor. When do you think the intersection of P4 and eBPF is headed? Where, sorry. And there is a fringe of activity around Cilium, Solo.io in the container networking community. Will this stop here?
So this is a question that I really wish we had a panel with someone like Kyle Mestry on the panel right now, I think, who would probably have a much more complete answer than I do. I mentioned his name partly because when he saw the eBPF compiler coming out, he within a week or something like that, he had written his own P4 program, compiled to eBPF, deployed it, and added table entries to it, and was asking detailed questions of Tamaz on the chat, some of the Slack communities. So I wish I had a better answer, and I would defer to an expert like him for a more complete answer that I think I could possibly give. I'm sorry.
That's fine. Thank you. There is one more question from Victor. What packet header new fields are needed to store data collected using P4 network monitoring? I think it's related to INT, but I guess if you can generalize it, there are different INT-like variants and also efforts in the industry and the standard bodies. Then where do you see them go into? Do you think they will converge, or they can actually, some of them evolve into something unique by themselves? So I know it's a bit bloated question.
No, but I mean, so one of the things I thought was interesting when I first read the INT specification, which was long after you and Mukesh had published it, I was catching up later and learning about it, is, even that specification is not, I wouldn't call it, it's a specification for one set of header formats. It's really kind of a family, and you get to mix and match and put it together in various ways with many choices. And I mean, I think that's the nature of P4 programmability, is when you have programmable network devices, you have so many choices that you don't have to necessarily settle on one header format, one way of putting the headers in. And so I think the main advantage in trying to standardize sets of headers is when you want to have it not just implemented on programmable devices, but implemented on what you call more fixed function devices, which tend to have a 2 or 3 year lead cycle before they come out with new changes like that. So, I mean, I guess to the extent that programmable devices, continue to capture, mind share and market share, you don't have to settle. I mean, you don't have to decide yet. That's one of you can decide later, and you can change them later in response to other devices. So I think the main reason, so that may be an obvious answer, but I see more of them being standardized because people want to implement them in other devices, and they'll want to have one way to do it that they can refer to for interoperability between devices is the main reason, and that will continue, I'm sure. But for those who are working on the new edge of things, they'll have the opportunity to experiment with programmable devices.
That's a great answer. I concur with you. I guess we can take it as a last question. Where can I get a tutorial to get started on P4DPDK?
Oh, that's a good question. I haven't written one. I mean, some people might know I have an open P4 guide repo I've done for years that I would point you at if you ask for the BMV2 software switch. I haven't updated for DPDK, and if I knew of one, I would gladly link to it from there, as well as other places. But I would recommend taking a look at the IPDK project. If you search for IPDK, and it's got a bunch of scripts for setting up mini open source tools and compiling and building them, including the DPDK backend, which I suspect that's the place I would start, and then ask questions of the maintainers of it if you get stuck.
Yeah, there is IPDK.io. I think the contents are coming up. Maybe not all of them are there yet, but please stay tuned over there. I think that could be a good starting point.
Yep.
Right. Thank you very much, Andy. This is awesome session.